So once again, this is a guided walkthrough video for the VulNyx platform's robot machine, and let us begin. All right, so the first thing we like to do when we do any of these CTF box CTF exercises is we like to run an nmap scan. So nmap is a program that's going to let you know what ports are open on a particular server on your network. So we're going to specify the IP address of the machine we want to scan, and then we're going to specify that we want to scan all the ports with this argument here, -p-. We want it to run very fast but not too fast with 4 threads with this argument here, -t4. We want nmap to run very verbose, which means that it's going to send us information before the scan is over with this argument here, -vv. And we're going to run common scripts with -s_C, and we're going to run versioning information with this flag here, -S_V. Okay, so let's run the nmap scan. Okay, so immediately we see that there are 3 ports open on the target. There's port 80, there's port 22, and there's this unusual port, which is 27,017. So we're going to see what exactly is running on these 3 ports when the scan finishes in just a few moments. Okay, so we've got our scan results back, and let's see what is running on the system. So on port 80, over here, we have HTTP, which is the standard web server port. It's running Apache software 2.4.56. So this is relatively up to date. It is, yes, this is the HTTPD, the daemon, and the HTTP title is Hello Friend. So we're going to be checking this out in just a little bit, but let's take a look at what else is running on these ports. We also have port 22, which is running the SSH service. It's running OpenSSH software version 8.4, and the anomalous port over here on port 27,017 is running MongoDB, so the Mongo database service, and this is version 5.0.21. And we also see that this is a Debian Linux system that we can tell from this piece of information over here. So all right, so we know that this MongoDB, this database system, is working. MongoDB is different from typical database systems because it is not an SQL system. It is what is known as a NoSQL system. And Matt the Techie says, is Debian 11 install from the SSH header? Okay. So the SSH header over here, Debian 11. Okay, this gives us a little more information about what kind of operating system is running in this environment. Okay, so what we're going to do is we're going to check out the web page. So we don't know if we have proper credentials to log into the database here. So we're going to take a look at the web server port, and we can do so from our web browser. So over here, we're just going to go over here, and we're going to access the web server at 0 to 80. And we see this this handsome man over here, and this is the main character from Mr. Robot. So what we need to do in this case is we need to download this file. So this image actually has some information in it, and we're just going to right-click and copy the image link, and then we're going to go back to our terminal. In the terminal, we're going to download the file with wget. So we're just going to use wget and paste in the URL for the image, and that's going to download the image to our attacker system. So after that, we could use something like exiftool to take a look at the metadata for this file here. And inside the metadata here, there's a comment. It says backup Elliot. So backup Elliot indicates a directory path on the web application. So we've got this, we have this web directory here. So what we're going to do is we're just going to copy this, and we're going to try to access this file path on the web server. So over here, we're going to paste in the file path, and we're going to make sure that we have our proper syntax. And then we have this this image of these. Well, this is also an image from the Mr. Robot show. So after we've discovered this particular endpoint, we can do some fuzzing. So what we're going to do is we're going to use GoBuster to fuzz this particular endpoint. So the endpoint here is backup Elliot, and we're going to try to find any extra subdirectories or any files inside of this directory by doing what is called directory busting. So the directory busting tool we're using is called GoBuster. So GoBuster is a very fast directory fuzzing tool, and we're going to run it with a particularly large word list over here, and we're going to run it against this endpoint here, backup Elliot. And in particular, what we're going to do is we're going to look for different file extensions. So with this argument here, we can specify the type of files that we're looking for. For example, we could look for PHP files, HTML, zip, back files, TXT files. So the problem here is that the more extensions you feed to GoBuster, the longer the scan is going to take. Each one of these extensions is going to increase the scan time by 100%, which means this would take 1, 2, 3, 4, 5 times as long as it would regularly take. But sometimes you really need to look for those files, and so this is necessary. Okay, so let's run the GoBuster scan. So we see here that we've found a couple of different endpoints. So this is a forbidden. This is also a forbidden. So code 403. We've got a couple of positive hits, code 200. So okay, so what did we just do? So we used the GoBuster tool to enumerate files and subdirectories on this endpoint that we found over here, backup Elliot, and we found this particular file right here called connect.back. So this is a backup file of some sort, and we definitely want to check this out. So what we're going to do is we're going to download this file using wget. So I'm just going to copy the this endpoint here, and then I'm going to go to another tab, and I'm just going to use wget and paste in the file that we want to get, which is the backup Elliot endpoint and backup Elliot subdirectory and the connect.back endpoint over here. So we download the file like this, and then what we want to do is we want to find out what's inside this file. So we can run the file command on connect.back. It's going to tell us that it is actually a PHP script in ASCII text. So what could be inside this PHP script? We can just read the file, and we see here that we have Mongo database credentials here. So this is for localhost, so I guess it's localhost to the system natively, and then an IP and a port over here. We've got a username, a password, and we have a database that we're going to be accessing, which is called Elliot. So we can use the MongoDB client on Kali Linux, and then we can access this information. So the command we're going to use is Mongo, and then the IP address, and then slash, and then the database we're going to access, which is Elliot. The username we're going to specify as Mongo, just like over here, and the password is MongoPass, just like this information over here. Okay, so go ahead and hit enter on that, and now we're we are accessing the Mongo database on the target server. So Mongo shell version, I think this is the client. This is the client, so this doesn't have anything to do with, yeah, the server is running this version over here. So MongoDB server version 5021. So it's important to take notes of these server versions because sometimes you can come across an exploit that takes advantage of particular software versions. That's not what we need to do in this case, but let's access what's inside the database here. So we're going to give this command over here to show the different databases in the system, show DBs. So we only have one database here. It's the one called Elliot. So we're going to enter that database by using this command, use Elliot. Okay. And then we're going to find all of the different information inside the Elliot database with this command. And the command is db.elliot. So the name of the element, the name of the database, and then we're going to use the find function, and we're going to make it pretty with this additional function over here. So we see here that the only thing inside the database is this information here. So we got some information about this Elliot user. So the first name is Elliot, their surname is Alderson, their nickname is Mr. Robot, and their birth date is the 17th of September, 1986. I think that's the format over here. So what we're going to do is we're going to use this information to build out a potential password list for this user over here, Elliot. And we're going to be using a particular script in order to do so. So let me introduce this script to you. So this is called the CUPP password creation script. So the CUPP, Common User Passwords Profiler, is a script used to create custom password lists based on user information such as legal names, nicknames and aliases, birthdays, family member names, and more. So after entering the user info into the script, it creates a custom list of possible passwords based on different iterations of the data that we feed into the CUPP script. So we're going to feed first name, last name, and birth dates and aliases, and it's going to make a custom list for potential passwords based on all this information right here. So in order to access the script over here, we're going to go and search for it. This is called the CUPP password script. And if you're interested in taking a look at the script yourself, you can do so over here. Okay, so we've got the GitHub project for the CUPP script. We're going to go to the code, and then we're going to copy the GitHub repository address. So after we've done that, we're going to go back to our terminal, and then here we're going to exit out of the MongoDB, and then we're going to git clone the repository here. Okay, so after that, we're going to enter the directory, which is called CUPP, and we see here that this is what we just downloaded here. We cloned the Git repository. We're going to run the CUPP script over here in interactive mode by giving the -I, and then we're going to give the information that we know about the Elliot user here. So we know that their first name is Elliot. We know that their surname is Alderson. We know that their nickname is Mr. Robot. We know that their birth date is 17091986. We do not know their partner's name, so we're just going to hit enter. We don't know any other information about about this user, so we're just going to skip all this. Do you want to add some keywords about the victim? No. Do you want to add special characters at the end of words? No. Do you want to add some random numbers at the end of words? No. Do we want to go into elite mode? No. And we're going to save dictionary to elliot.txt, and we're going to create 1,614 words. Hyperspeed print, let's say yes. Okay, now load you Pistolero with elliot.txt and shoot. Good luck. All right, so let's take a look at what this elliot.txt file is. So cat elliot.txt. Okay, so what the script does is it creates a bunch of different iterations of the information that is given to us. So we see here that Elliot here is spelled backwards, and then some numbers that are associated with the user's birthday. There are also common year numbers over here as well, going up until 2020, but I guess it hasn't been updated for to modern times, otherwise it would go up until 2024. But so it's got a lot of different iterations over here that we could use for potential passwords for the Elliot user. So what are we going to do with this? We're going to do some brute forcing. So the next thing we're going to do is we're going to use the Hydra tool. So we're going to use the Hydra tool to try to brute force Elliot's password based on the elliot.txt list that we created here. So the user is going to be Elliot, and the password list that we're going to give to the Hydra tool here is going to be elliot.txt. And we need to give an IP address. In this case, it's 80. Okay, so this brute force attack is going to try to log in as Elliot using all of the different passwords in the elliot.txt file. And when it finds a match, it's going to tell us. So we're going to run the tool, and this is going to take a little while to run because SSH brute forcing is kind of slow. But in this case, for this CTF box, we were able to do SSH brute forcing because there were no security measures in place, and we were able to log in as the Elliot user. Well, we were able to get the Elliot user's password because we created the custom password list using the CUPP script. So what we're going to do is we're going to break into the server as Elliot using this password. All right, so we need to do SSH Elliot at the IP address here. It's going to ask for the password. We can just grab this password that we brute forced and then paste it in. And when we ask who we are the Elliot user. So we've successfully broken into a server, and whenever we break into a server on this channel, we put on the scary hacker voice.
Hey everybody, this is Scary Hacker Voice. Every time we break into a server, we have to put on Scary Hacker Voice and laugh maniacally. Then say, "We're in."
Let's continue. All right, so this so this box actually has a gauntlet for us to work through, and what we're going to do is we're going to find out what sudo permissions we have by giving this command right here, sudo l. And sudo l is going to tell us what elevated permissions we have for different commands. And in this case, user Elliot may run the following commands on Robot. As the Darlene user, with no password, they can run user bin sh. So this means that we can become the Darlene user because we can start up a shell as the Darlene user using sudo. So the way, I've got a little presentation on this, just a second. Okay, so this is privilege escalation, sudo sh, and sh is one of several shell programs on Linux Unix systems. If we're able to run sh with sudo, we're able to elevate our privileges with a command similar to one illustrated above rather, and we just need to give sudo sh to start up a shell. Okay, so we're going to give the command to become the Darlene user, so it's sudo and then we have to specify the user, which is Darlene, and then the command, which is sh. So when we give this command, we're going to give this command in the context of the Darlene user and start up a shell. So when we give the command, we see the so sh is a very early shell program, so we don't have very much of a prompt. So all we see here is the $sign that says that we are a normal user. We ask who am I? It says we are Darlene. We can actually upgrade our shell a little bit with Python. So we're going to find out which Python program is running on the program on this server. So there's Python 3. We can upgrade our shell a little bit by using Python C, Python 3, C, and then give this command here, import pty, and then pty.spawn bin bash. And that's going to give us a bash shell instead of an sh shell. So now we have a bash shell instead of an sh shell. So the next step is to figure out what Darlene can do. So we use sudo l to figure that out. And it says user Darlene may run the following commands on robot. As Angela, the user Angela with no password, we can run Python 3. So we actually just illustrated how to create to elevator privileges with Python 3. But let's take a further look. So this is privilege escalation sudo Python. Python is a very popular scripting language that can be used for a lot of different purposes. If we can run Python with sudo, then we can elevate our privileges by using commands similar to the one illustrated above. Let's see. So we've got sudo Python, and then give a command import os. So import this module here, and then give this os function over os module function system bin sh to open up an sh shell. The next thing we need to do is we need to sudo user Angela, and then we're going to do Python 3, and we're going to do the command import os, os dot, is it os system? Os system, right? Os system bin, let's do bin bash instead of bin sh. Okay, and when we ask who am I, we're now the Angela user. Okay, so we're now the Angela user, and there are a couple more users to work through here. We're going to do sudo l again to figure out what privileges would sudo Angela has. And it says here that user Angela may run the following commands on robot. As the Tyrell user with no password, they can use user bin awk. So what is the awk program? Let's take a look. So privilege escalation sudo awk. Awk is a Linux Unix binary that can be used for text formatting. It is very useful when we want to manipulate or replace characters in command output. It can be used to manipulate and replace characters in command output. And if we're able to use awk with sudo, we can escalate our privileges by using a command similar to the one illustrated above. So we can actually run different system commands inside of awk, which actually makes it vulnerable to privilege escalation if we're able to run awk in an elevated context. Okay, so sudo awk begin system bin sh. So I guess we're going to use this command over here to start up a sh shell as the Tyrell user. So we're going to do sudo u Tyrell, and it's going to be, let me get the command. So it's going to be awk and then begin system in here, bin bash, and I think we need to encase this in double quotes. Yeah, okay, I think this is it. Okay, so we are now the Tyrell user. So Tyrell at robot, who am I? We are now the Tyrell user. So I think this is the last one. This is the last one of this Matryoshka doll of different pseudo privilege escalations. So if we ask Tyrell what their pseudo permissions are on this box, user Tyrell may run the following commands on robot. As root with no password, we can run user bin zzuf. So I actually didn't know what the zzuf binary was before doing this box. I had to do a little bit of research, and what the zzuf command is zzuf is a transparent application input fuzzer. It works by intercepting file operations and changing random bits in the program's input. zzuf's behavior is deterministic, making it easy to reproduce bugs. So it's basically a fuzzing program that you can run with different binaries to test the limits, to do limit testing or to do security testing. It's an input fuzzer, yes. So zzuf's program is an application input fuzzer, which can be used to test the security and stability of different programs. If we can use the zzuf program with sudo, we can escalate privileges by using a command like the one illustrated above. So we just run zzuf with the bash shell, and then we're going to open up a bash shell. And because we're using sudo, it's going to open up a root bash shell. So let's do that. So we just need to do, let's clear off. So sudo zzuf bash. When we ask who am I, it says we are now root. So we've now rooted the box, which means we give this redeem.
What are you? I'm system root.
So that is a scene from the 1989 Batman movie. If you saw that movie in the movie theater as it came out, then you're probably really old because it's from 1989. All right, so we're very close to finishing today's exercise. All we need to do is we need to move into the root directory, and then we need to read this file right here, which is called root.txt. Only we're not going to read the root.txt file because the organizers at the VulNyx website have requested that people doing write-ups and videos on their machines not reveal the contents of the flags. So what we're going to do instead is we're going to redirect the output from catroot.txt into a file called iReadRoot.txt, and then we're going to run md5 sum on both of those files. And we're going to do that to prove that we actually read the file and had access to it. Does that md5 sum doesn't look like it's the same. iReadRoot.txt, root.txt, they're both 33. Okay, let's try that again. md5 sum root.txt iReadRoot.txt. They are the same file size. I don't understand why they wouldn't have the same md5 sum. Oh, maybe because the file permissions are not the same. But regardless, I was able to access the root.txt file and then redirect the output into another file, which means I was able to access the file. So I've effectively finished the exercise, although I'm not. Usually this works. Usually when I do md5 sum on both of these files, it gives us the same md5 hash. So That's a bit of a mystery. If anybody knows, please let us know in the video comments. But that was a guided walkthrough for the VulNyx robot machine on VulNyx.com. Thank you very much for watching, and we'll see you next time.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.